Hi guys, welcome back to this channel. Here we're gonna have homework 4, question 2. So let's first read the question. Find the current in the R2 resistor in the drawing. So this question has a figure. So let's analyze it first. For electric circle, we need to always consider about simplify it. So for this question, can we do that? Can we simplify it? The answer is no, right? Because we have two batteries here. We cannot easily simplify it as what we do in homework 3. So what should we do? So for this kind of question, like have multiple batteries, I think it is the trickiest part among all the questions about electric circuit, because we're gonna use a very special rule, which is this. Okay, this is actually my own notes while I was taking this course. So using these rules, I don't know how to pronounce this, so let's just skip it. For this rule, the rule is used to solving complex circuits which includes several batteries that cannot be simplified, which is exactly this one, right? It has two batteries, so we cannot simplify it. So we have to use this rule. Also for this question, like it is 100% gonna show up on your exam. So please make sure you know how to like solve this problem. All right. So first, let's look at the first rule. It's also called junction rule. It says the sum of all current entering any junction point equals the sum of all currents leaving the junction point. So let's just apply it to this circuit first. All right. So first, it doesn't really matter. Okay, for the first drawing you're gonna make, it just doesn't matter. You can draw it here or here, or wait. You can draw it here, go this way, or go this way, or go this way. Doesn't matter. Okay, I'm gonna draw it in this way. Alright, I'm gonna name it I3, and this is the one entering this junction point. And then the current is gonna become these two currents. I'm gonna name them I2 and I1. Why would I name it I1? Because it's gonna go all the way here. And I1. Right? So based on the first rule, the sum of all currents entering any junction point equals to the sum of all currents leaving the junction point. So we can have an equation here, which is I3 equals I1 plus I2. Right? Here. So then, next. Okay, for this question, we're looking for the current in the R2 resistor. So we're actually looking for this current, right? But in order to like figure out what it is, we need to also know what I3 and I1 what they are, right? So we can't just, because we have multiple unknown variables, we have to like have multiple equations here. So try to like manipulate them so they can cancel out each other, only have I2 left. All right. So now in order to have like more equations, we now is gonna like have second rule. So the second rule, also called loop rule, it says the sum of all the gains and losses of potential around any closed path must be zero. Closed path. So if you have watched the lecture videos from Professor Brockomir, you know that we're gonna draw closed path on the circuit. So Okay, first, okay, this is very important, all right? So this is the thing that you have to do before like you draw the closer path, because after this moment, if you don't like actually mark this, you're gonna get lost later on. So we're gonna like, so we know, okay, I have this picture here. While I was taking this note, this picture is like for telling me the current is go from the side that has higher electrical potential to where it has lower potential. All right. So from rule 1, we have these 3 currents, and we're gonna mark the higher potential and lower potential right now, right here. So plus, minus, plus, minus, right? Because the current go from the side has higher potential to lower potential, right? We mark them here. So okay, let me, purple is for rule 1, and let's see, green is for rule 2. All right, so now we're gonna look at rule, second rule. Here we need to draw close the path, right? It doesn't matter which direction you choose. So let me just random use clockwise for both of them. All right, clockwise. This is circle 1. This is circle 2. So first, let's write the equation down. First, it says all gains and losses of potential around the path must be like 0. So let's look at it. For this, it is a closed path, right? So this part, this circuit, is go clockwise. So for this side, it goes here like this, right? So let's analyze it one side by one side. So let's look at this side. Nothing here. Then we look at this side. We have a battery here. Is it gain or loss? Here we know that positive, negative, positive, negative. So here we go from this side to this side, right? We go from the negative side where it has lower electrical potential to where it has higher electrical potential. So it is a gain, right? We're from lower to higher. It's a gain. So okay, let me just write this down first. Oops. So the sum would be 0, right? So it should be right. This is the circle 1, right? So first of all, let's say that V1 is a gain, so it's positive. So we can plus 10. Now let's look at the second term, which is this side. So is it gain or loss? It is a gain. Oh wait, it is a loss. Sorry, it is a loss, right? It goes from higher to lower, right? This plus is minus, higher to lower. So it's a loss. So we need to minus R1 is 2 ohm to. Okay, then next term. We're looking at this side. Is it gain or loss? So obviously loss, right? Because higher, lower. We go from higher to lower, loss. So we lost, we minus 2.1 equals 0, right? So here, you might ask, why would we need plus and minus? Because it is always go this way, right? Okay. How? Oh my god, how do I actually explain this? So this part is actually sometimes confuse me, even though I know how to solve these questions, but it still confuses me because like why there's some confusion here, because the direction I choose. So in rule 1, right? Notice the purple drawing. In rule 1, I choose the direction of the current go this way, right? But at the second rule, I again choose the direction go this way, which makes the purple marks seems useless. Alright, because like we don't need these marks to tell us which one has a higher, which one has lower, because like it just go this way, right? So what if we choose direction in this way? What's gonna happen? Let's see. Okay, use another color. It's green. Okay. So what if we choose a direction to be like counterclockwise? Still these four sides, right? So first for V1, we go this way. It's a gain or loss. It's a loss. So this time 10 is gonna be negative, right? And then this side, nothing. This side is a gain or loss. At this time, because the direction is different, it's a gain now, right? Because from negative to positive, from lower to higher, it is a gain now. So it's plus 2.1 R3, I3. And then this side, from lower to higher, it's a gain now. So it's plus 2. So here we know that it doesn't matter which direction you choose. As long as you like mark all this, you wouldn't like, it can avoid the trivial mistakes, because this marks are super important. It really can help you out from like a loss in all this stuff. So based on these two equations, we know that like they're the same, right? There is actually the same. If we like times -1 both sides, this is gonna be plus net minus minus, right? It's the same. So so this is just an example, right? This is not what we're gonna do. We're still gonna follow the, what do we have here? We use 2 as circle 2, also clockwise. Alright, so let's look at this circle 2. Circle 2 is V2 plus I2R2 plus I3R3 equals 0. 0. Alright, so let's look at V2. So V2 go this way. V2 go down. Down it's higher, lower, it is a loss. Alright, so it's -22 this side. From lower to higher, it's a gain. So plus this side, lower to higher, it's a gain, right? Plus, right? So now we have 3 equations for 3 unknown variables. So this is enough, because like for figure out what are they. So now we have this equations. Let's write it down here. Okay, let's move the variables in one side and the constant at another side. Okay, how do we Okay, first 1, 2, 3. Okay, let's first substitute this one, equation 1, 2, equation 2, and equation 3. Okay, so let's first remove these variables. So like we want this one disappear. So if I3 disappear, we only have 2 variables, right? So we're gonna write it as here. Write it as right. And also for equation 3, we have 2 plus. Wait, am I okay? No, here. It's not I3, it's I2, right? Let's see. Where did I? Okay, I'm already lost. I'm losing my mind now. So 2 times I1 plus 2.1 I1 plus 2.1 I2. All right. Okay. That's why I said that this is the most tricky part of the whole like homework 3 and homework 4. It's super demanding. So for equation 3, it's 1.9 times I2 plus 2.1 I1 2.1 I2 equals 22. So this is equation 4, equation 5. Now here, let's simplify it to 4.1 R1 plus 2.1 R2 equals 10. Then let's simplify equation 5. It is 2.1 plus 4 I2 equals 22, 7. All right, cool. Now we're looking for I2 here, right? So now let's substitute which we want this, we want have this at the end, left it to the end. So now we're gonna substitute I1 into this equation so we can like remove I1, so only I2 left. All right, so first let's using equation 6. So I1 equals I1 equals 4.1 and the numerator is 10. Wait, how do I, oh yeah, minus 2.1 equals calculator. Where is it? Here. We have okay, 10 over 4.1, which is 2.44 minus 2.1 over 4.1, which is 0.51 I2 here, right? So now we substitute the equation 8 to equation 7, so we can figure out what's going on about like I2, right? So now here we have 2.1 times I1 plus 4 I2 equals 22. Alright, so now only one variable left, which is I2, which is the current in R2 resistor, which is the one we're looking for. So finally, the final step. So we have 2.1 times 2.54, which is 5.124 minus 2.1 times 512, which is minus 1.075 I2 plus 4 I2 equals 22. Then 4 minus this number is 2.9248 equals 22 minus 5.124, which is 16.876. Wait, where's I2? Oh, I forgot to write it. Oh my god, I'm losing my mind. I2 here. Right, okay. So final step. I2 equals 16 over 2.9248 equals 5.77 ampere. Alright, this is the final answer. I might have some calculation mistakes, so if you have any questions, or if my answer is different from yours, please let me know. So also for this kind of question, we can actually examine our answer. We can can we? Okay, actually let's end it here because I'm really losing my mind now. So if you have any questions, please let me know. I think this is not the only one questions that we're gonna use this rule here. So see you guys next question, and we're probably gonna use this rules in homework 4 later on. Okay, that's it. Bye.